Hello everyone. In this video, we are going to see how to migrate an on-premise application to the cloud. These are the topics we are going to cover in this video. What is AWS? Basic concepts of AWS. What is migration? Why do we need migration? Different phases of AWS migration. Application migration strategy, simply the 6 R's. What are the benefits of AWS migration? Few services you be used in AWS migration. First, we'll start with what is AWS. AWS is the world's most comprehensive and broadly adopted cloud platform, offering over 165 fully featured services from data centers globally. Millions of customers, including fastest growing startups, largest enterprises, and leading government agencies, trust AWS to power their infrastructure, become more agile, and lower costs. Simply, AWS is easy to use computing platform offered by Amazon. The platform is developed with a combination of infrastructure as a service, platform as a service, software as a service. We'll start with infrastructure as a service. In this service, the cloud provider provides the customer with virtual machines and other resources as a service. They abstract the user from the physical machine, location, data partitioning, etc. If the user wants a Linux machine, he gets a Linux machine. He will not worry about the physical machine or the networking of the system on which the OS is installed. Example is AWS EC2. Next, platform as a service. In this service, the cloud provider gives the ability to the customer to deploy custom-created applications using programming languages, tools, etc. that are provided by the cloud provider only. The customer cannot control the underlying architecture, including operating systems, storage, servers, etc. This service provides you a platform for developing applications like Google App Engine. Next, software as a service. In this service, the cloud provider leases applications or the softwares which are owned by them to its client. The client can access these softwares on any device which is connected to the internet. Only they need tools such as web browser, an app, etc. For example, a company called Salesforce.com provides the customer relation manager on a cloud infrastructure to its client and charges them for it. But the software is owned by the Salesforce company only. Before we move into migration, we should know some of the basic concepts such as cloud computing, data center, and virtualization. We'll start with cloud computing. Cloud computing means storing or accessing your data and programs over the internet rather than your hard drive. Cloud computing is a set of principles and approaches to deliver compute, network and storage, infrastructure resources, services, platforms, and applications to users on demand across any network. These infrastructure resources, services, and applications are sourced from clouds, which are pools of virtual resources orchestrated by the management and automation software so that they can be accessed by the users on demand through self-service portals supported by automatic scaling and dynamic resource allocation. In simple terms, a cloud is what you use buy from data center. Nowadays, everything is moved to the cloud, running in the cloud, accessed from the cloud, or maybe stored in the cloud. This could be a big deal for you, primarily because of three main reasons. You do not have to maintain or administer any infrastructure for the same. It will never ever run out of the capacity since it is virtually infinite. You can access your cloud-based applications from anywhere. You just need a device which can be connected to the internet. What is data center and virtualization? A data center is a bunch of servers, storage, and backup connected to the network. It is a physical server center in which servers are located. What is virtualization? It is a technology that allowed you to create multiple simulated environments or dedicated resources from a single physical hardware system. Software called a hypervisor connects directly to that hardware and allows you to split single system into separate, distinct, and secure environments known as virtual machines. These virtual machines rely on the hypervisor's ability to separate the machine's resources from the hardware and distribute them appropriately. Now I'll tell you the difference between cloud and virtualization. Virtualization is a technology which is used to create multiple simulated environments from single physical hardware, whereas cloud is a methodology which is used to pool and automate virtual resources for on-demand. Virtualization is used to deliver packaged resources to specific users for a specific purpose, whereas cloud is used to deliver variable resources to group of users for a variety of purposes. Virtualization is the image-based configuration, whereas cloud is a template-based configuration. When we consider lifespan of the cloud and the virtualization is for years and years, it's for long term, whereas cloud is for short term, from hours to months. Now we'll see what is migration. Migrating your project means moving your data from the on-premise data center to the cloud. As you know, cloud is the virtualization used over a data center to make the functionality more flexible. Example, GoDaddy and Expedia like companies move their entire data to the cloud. Irrespective of the business, organization always experience competition. Hence, staying updated with the market needs, time becomes an integral constraint. What if there was a way business could focus on their business goals and outsource their maintenance and monitoring tasks somewhere else? Would that help save time and meet the market needs with more efficiency? Yes, migrating to cloud saves time and meets the market needs with more efficiency. This AWS migration video would walk you through all the necessary points that you need to consider before you plan to migrate to cloud. Why do we need migration? Business is no easy task when it comes to handling situations like security, scaling up or down, etc. Let's look into few scenarios. Why do we need migration? First, your project has started receiving a high volume of traffic in the night time. Next, if your client wants fast application implementation and deployment. Third scenario is it's becoming expensive to manage the growing database needs. If you are cautious about the mishap of data center going down. If you migrate to cloud, then the problems I said above will be handled automatically. Now that you have a fair idea what cloud and migration is, just think about your daily activities online. You will realize that a lot of work you do is online based, like your social media interactions, your online shopping, paying electricity bills, all are related to cloud. We'll see better through an example. There is application called Customer Relation Manager, which is based on the cloud. This software is highly used in all the sales organizations for better agility, enhanced productivity, and low cost. The way it is used is a field sales representative would need an access to a mobile device which is connected to the internet, and then he can retrieve the customer information irrespective of his location. Also, he can update the information on the go. Therefore, no need of going back to the office to update the deal information. The sales managers can also monitor everything on the internet enabled devices and will know which deals to close or not. The best part is you do not have to buy any machines or administer any kind of software. It all will be handled by the cloud company which is running these applications. Now, how will you move your data to the cloud? That are different phases of AWS migration. Data migration means moving your data from one location to another. It is more complex as the process involves different phases. First phase is discovery phase, and the second phase is cloud assessment phase. Third, proof of concept phase, and fourth is application migration phase, and the fifth phase is enterprise cloud operation phase. We'll see the first phase. Sometimes you need not require to move your entire business to the cloud. This is where segregation is important. You need to identify the applications which can be migrated and which cannot be migrated. What we'll see next phase, that is phase 2. We need to choose the method for AWS migration. Phase 2. Choosing your migration method. Depending on the data, AWS provides different ways to migrate your application. Example, AWS Snowball, AWS Snow Mobile, AWS Direct Connect. What is AWS Snowball? It is a data transport solution that accelerates moving terabytes to petabytes of data into and out of AWS using storage devices designed to be secure for physical transport. Using Snowball, it, it helps to eliminate the challenges that can be encountered with a large-scale data transfers, including high network costs, long transfer times, and security concerns. What is AWS Snow Mobile? It is the first exabyte scale data migration service that allows you to move very large data sets from an on-premise to AWS. Snow Mobile is a secure data thread with up to 100 petabyte storage capacity that can be dispatched to a site and connected directly to a network backbone to perform high-speed data migration. You can quickly migrate an exabyte of data with 10 Snow Mobiles in parallel from a single location or multiple data centers. Snow Mobile is offered by AWS as a managed service. What is the difference between Snow Mobile and the Snowball? To migrate large data sets of 10 petabyte or more in a single location, you should use Snow Mobile. For datasets less than 10 petabyte or distributed in multiple locations, you should use Snowball. In addition, you should evaluate the amount of available bandwidth in your network backbone. If you have high-speed backbone with hundreds of GBs of spare throughput, then you can use Snow Mobile to migrate the large datasets all at once. If you have limited bandwidth on your backbone, you should consider using multiple Snowballs to migrate the data incrementally. What is AWS Direct Connect? It is a network service that provides an alternative to using the internet to connect to customers' on-premise sites to AWS. Using Direct Connect, data that would have previously been transported over the internet can now be delivered through a private network connection between AWS and your data center or corporate network. In many situations, private network connections can reduce cost, increase bandwidth, and provide a more consistent network experience than internet-based connections. Phase 3. This is the proof of concept phase for AWS storage. Once you know how and what you are migrating, next you have to figure out how and where you will store it. The entire motive of moving to AWS to minimize expenses. In this proof of concept phase, you will test your workload and understand about AWS storage service, their benefits, limitations, and the necessary security control. Phase 4. Now that you have all the prerequisites like the blueprint, migration tools, list of assignments, backups, and its synchronization with your on-premises data repositories ready in your application migration phase. Once you have migrated your project to cloud, reliability and durability are the added benefits you get. Phase 5. Enterprise cloud operations. You have already migrated to AWS, and now AWS will bring updates that you'll need to incorporate in your existing architecture. You must ensure that you have 24/7 support team keeping track of system maintenance and upgrades after the migration. What are the different application migration strategies? The complexity of migrating existing application varies depending on the architecture. Amazon came up with different strategies which are commonly called as 6 Rs. Rehost, replatform, repurchase, refactor, retire, retain. We'll start with rehost. If you have an application ready and working, then you can simply rehost it on AWS. Also, it is referred as lift and shift. You lift your services and applications from your hosting environment and shift them to the cloud using a third-party exporting tool. What is replatform? If you have an outdated version of your application running on your hosting environment, so that you have to modify your application and then rehost it. Replatform is a modification of lift and shift. It involves optimizing the cloud architecture to achieve the benefits without changing the core architecture of the application. The third one is repurchase. There would be certain applications that wouldn't be compatible with the new architecture. In that case, you need to purchase a new application for the new architecture. AWS Marketplace provides a wide range of services that pay as you use model. Repurchase is also referred to as drop and shop. When you upgrade, ease the application, accept the new architecture, and make changes to the existing model. Fourth is refactor. You want to add up new features, scale up the limits of the existing business model and performance that are difficult with the existing environment. You reconsider your needs, though the solution is a bit expensive. Improving your business by moving to a service-oriented architecture will benefit your business in the longer run. Fifth one is retire. After AWS migration, you can differentiate between useful and useless resources. Hence, you can cut off all the resources that are no longer useful to the business and build a strategy around the new resources. This will cut down the extra costs. With lesser things to worry about now, you can focus on maintaining the resources used by the new business model. Next is retain. As you know, the sections of a project you need to migrate, you can simply use any of the above mentioned strategies. Build a strategy first to retain those applications according to a business model which is ready to migrate or the applications that were upgraded recently. One can choose wisely one method from these 6 R's during AWS migration. Next, we'll see what are the benefits of AWS migration. First is elasticity. Adding and removing capacity whenever it is needed is the greatest benefits of elasticity. Disaster recovery. With a 99.95% guaranteed uptime, businesses can be confident knowing that their data will always be available. Enhanced cost management. The infrastructure as a service platform provides two major benefits. First, such as Amazon Web Services is available as a monthly service. Secondly, it eliminates the need to continue to purchase and maintain the physical hardware. We'll see few services which is related to AWS migration. AWS Migration Hub. AWS provides a single location for tracking migration process. Migration Hub gives you the freedom to choose the migration partner and tools that fit your needs. AWS Server Migration Service. AWS Server Migration Service is an agentless service that helps migrate loads of on-premise workload to AWS easier and faster. It allows you to automate migration and track replication of server. It makes coordinating with your large-scale server migration easy. Amazon S3 transfer acceleration. This makes the transfer of files over long range to AWS S3 bucket faster and secure. AWS Snowball. It is a petabyte scale data transfer solution that uses secure devices to transfer large amount of data in and out of AWS. AWS Snowmobile. These are the topics I have covered earlier. It is an exabyte scale data transfer solution to move an extremely large amount of data to AWS. Snowmobile makes the transfer of massive volumes of data easier. Amazon Kinesis Firehose. It is the easiest out of all the services. It can capture and automatically load streaming data into Amazon S3. You can analyze real-time data to get timely insights of migration. We'll see one use case. Migrating web applications to the AWS cloud. This is the architecture diagram of companyacloud.com before and after migration. Companyacloud.com is a customer-facing web application of Company A, which serves as a marketing portal and a customer management system. Customers, partners, and employees use the web application to collaborate with each other using a rich web interface that can be viewed in a standard internet browser. CompanyACloud.com lists a complete catalog of products and their details. As a new product announcements are made, marketing campaigns generate substantial amounts of traffic to the site, resulting in periodic spikes. Outside of the time frames caused by these spikes, company acloud.com experiences a fairly steady and predictable traffic load, which is characteristically high on weekdays and low on weekends. The website is currently hosted on dedicated infrastructure at the company's headquarters. We'll see motivation for migration. Company A would like to move the web app to the cloud environment for three main reasons. First, addresses the growing traffic without investing in new hardware. Then, cut down the administration cost by automatic deployments. Finally, the company would like to expand and provision extra capacity only when it is needed, that is during running marketing campaigns. We'll see application architecture first. What they have used here. Using a standard three-tier application architecture, the company deploys a front-end hardware-based load balancer which manages traffic across two Apache web servers, each running on a separate physical box. Maybe if I take the picture, you can understand it better. Yeah. The application is running behind the company firewall and uses the standard SSL encryption. The backend business logic is implemented in Java and leverages Tomcat as application container and application server. The three Tomcat servers power the website. The application also had a database layer which consists of one master MySQL server and two slave servers for the greater performance. We'll see migration plan, strategy and execution steps. First is cloud assessment. On financial assessment, the technical program manager from the website development team was able to map the hardware configuration of physical servers, equivalent EC2 instance types, and estimate the combined storage and bandwidth requirements. The team realized that they could free up the current infrastructure for other internal projects, discontinue a tape backup maintenance contract, and reduce their operating expenditures by 30%. During the technical assessment, they discovered the entire company cloud.com technology stack was compatible with AWS and could run on EC2 instances with Linux. They also discovered that the web app can be configured to run at peak capacity 7 servers during campaigns, medium capacity 4 servers on weekdays, and low capacity 2 servers on weekends. Next, we'll see proof of concept. The web development team was skeptical about the relational database migration. To test, they decided to build a proof of concept application. During the proof of concept, the team learned the following techniques: starting, testing, and terminating, configuring Amazon EC2 instances and Amazon RDS DB instances, storing and retrieving Amazon S3 objects, and setting up elastic load balancers using the AWS Management Console. They learned a ton about AWS and saw that they have full control over the environment and felt a lot more confident about moving to the next step. The relational database files, binary and transaction logs were moved to Amazon RDS instance using the standard MySQL port utility. For the test environment, they deployed a DB instance with a single availability zone, and for the production environment, they set up a DB instance with multiple availability zone deployment to increase the availability. The team was able to successfully test and migrate all the data to DB instance and get performance metrics using Amazon CloudWatch. And they set the migration retention policies for backups. They built migration scripts to automate the process and create awareness within the organization by organizing a brown bag session. and successfully demonstrated their work to their peers. Application migration. Once the proof of concept was complete, the team decided to move all the application static files, that is images, JS, CSS, video, audio and static HTML content into Amazon S3 bucket. Created a CloudFront distribution of that Amazon S3 bucket and modified the references in web pages so that end users get the content directly from Amazon S3 and Amazon CloudFront. With a few scripts and AWS SDK for Java library, they were able to transfer all the data from tape drives and upload it to Amazon S3. During the application migration phase, the development team launched both small and large instances for their web and Tomcat servers. They created AMIs, Amazon Machine Images, basically called Golden System Images, for each server type. AMIs were designed to boot directly from an EBS volume and fetch the latest WAR file binaries during launch from the source code repository. They modified their build and deployment scripts to use the cloud as the endpoint. Security groups were defined to isolate web servers from the applications and database servers. Functional testing, load and performance testing was performed to ensure that the systems were performing at expected levels and that exit criteria for each component were met. Coexistence phase. During the migration phase, the location infrastructure was not deprecated immediately. Company A employed a hybrid migration strategy during the migration of all web and application servers. The configuration of the on-premise hardware load balancer was modified to send the request to the new instances in the cloud. For a shorter duration, the load balancer was routing traffic to the servers in the cloud as well as in the physical servers. After verifying that the servers in the cloud were performing at required levels, the physical servers were dismissed one by one. The load balancer were updated and all of the web traffic was being served up by the EC2 instances running in the cloud. After testing was completed, DNS was switched to point to the cloud-based web servers and the application was fully migrated to the AWS cloud. Leveraging the cloud. Once the production site was launched, Company E was looking forward to the time when they could use some of the advanced features of AWS. The team automated some processes so that once the server is started, it could be easily attached to the topology. They created an auto-scaling group of web servers and were able to provision more capacity automatically when specific resources reach certain threshold. That is when Apache Web Servers utilizes the CPU above 80% for 10 minutes. The team invested some time and resources in streamlining the development and testing process to make it easy to clone the testing environments. They gained lot of experience using AWS resources and also invested time in leveraging multiple availability zones for even higher availability. Optimization. During the optimization phase, the development team analyzed their utilization patterns and realized that they could save 30% if they switched to reserved instances. They purchased 4 reserved instances, 2 for web servers and other 2 for Tomcat servers. They built additional scripts to run their web applications in 3 different modes: weekend, weekday and promotion mode. These modes define the minimum number of servers to run. The team also integrated Amazon Cloud Watch into their existing dashboards so that they can monitor the system metrics of every instance in their cloud feed. Conclusion. The company was able to successfully migrate an existing web application to the AWS cloud. With minimal effort, the team was not only able to free up the physical infrastructure for other products, but also reduce the operating expenditure by 30%. Using the phase-driven approach, The development team was able to resolve all the financial, technical, and social political concerns. Deciding to invest in proof of concept proved extremely valuable. The resulting architecture was not only elastic and scalable, but also flexible and easier to maintain. Now you can start with your questions.